So good morning, good afternoon, and good evening, everyone. And thank you very much for joining today's PREZODE webinar entitled Climate Change, Super Driver of Zoonotic Disease Emergence. This timely discussion comes at a critical moment for global health, and not only because many of us are currently facing some heat waves in different parts of the world, but mainly because the world today continues to face the long-term consequences of the COVID-19 pandemic while facing the mounting pressures of climate change and biodiversity loss. Zoonotic diseases that spill over from animals to humans have been responsible for some of the most significant public health crises of our time. While their emergence is driven by a complex web of factors, so which includes biodiversity loss, changes in land use, agricultural expansion, and wildlife trade, climate change is increasingly recognized as a central amplifying force in this equation. Rising global temperatures, shifting rainfall patterns, and the increasing frequency of extreme weather events are profoundly altering ecosystems. These changes affect the distribution and behavior of wildlife, vectors, like mosquitoes and ticks, but not only, and the pathogens they carry. And at the same time, climate-related habitat disruptions are forcing wildlife into closer contact with humans and livestock, which create more frequent opportunities for zoonotic spillover events. The resulting feedback loop where human activity degrades ecosystems, leading to both climate change and biodiversity loss, further compounds the risks to global health. In this webinar today, we will discuss how climate change acts not just as a background condition, but as a super driver that accelerates the emergence, spread, and severity of zoonotic disease. And with our four excellent speakers, we will therefore examine this cross-cutting issue. Today, let's explore how we can strengthen global synergies, increase public and policymakers' awareness, and translate science into action to prevent the next pandemic. So let me introduce to our four speakers, Dr. John Epstein, epidemiologist and founder of One Health Science from the United States, Dr. Gladys Kalema-Zikusoka, founder and chief executive officer of Conservation Through Public Health and the UNEP Champions of the Earth from Uganda, Professor Jan Semenza, environmental epidemiologist from Department of Sustainable Health at Umeå University and Heidelberg University of Global Health from Sweden, and Dr. Cyril Caminade, physicist, climatologist, and specialist of early warning systems at Abdus Salam International Center for Theoretical Physics from Italy. Thank you very much to the four of you for joining today for this discussion. So there won't be no presentation. We aim for a roundtable format, so a dynamic discussion among all the speakers. And there is a Q&A box. If the audience wants to ask questions, we will try to keep 10-15 minutes at the end of our discussion to answer the question you may have. And now let's begin. So with my first question for you, John. So I would like to ask you how climate change and zoonotic disease emergence can be linked.
Well, thank you, Elsa. And I just wanted to begin by thanking you and Catherine and PREZODE for organizing this webinar. It's not only an important topic, but it's very timely. We were discussing earlier how we're all on the tail end of a massive heat wave. I'm here in New York, and we've had temperatures near 35 degrees for the past 4 days, which is near record highs. And so it sets the scene well for discussing the importance of climate change. And to talk about how climate change impacts epidemics, I think it's important to start with what we know about the major drivers of epidemics, particularly zoonotic diseases, those that spill over or jump from wildlife reservoirs into livestock or people. And it really helps understand how these are connected. The major drivers, the major human activities that we know facilitate spillover and emergence of zoonoses are land use change, which includes deforestation, but isn't limited to deforestation. It's any alteration of a landscape that influences the ecology, the assembly of biodiversity and people, and influences how we interact. The second one is livestock production, particularly the intensification of livestock production without adequate biosecurity. So as demand for animal protein grows with human population, we see growing and expanding farming systems that tend to be intensive. And if there's an adequate barrier between wildlife, which tend to be reservoirs for zoonotic pathogens, and the livestock we're growing, then we get spillover. And so when we look at these two things, which represent two of the major drivers for disease emergence, and then we look at the drivers of climate change, we see how closely these are linked, because things like deforestation and livestock production are major drivers and contributors to climate change. So we have two of our biggest global health challenges, epidemics and climate change, linked by what causes them. And then interestingly, climate change itself is a driver of disease emergence, because as we'll talk about today, it's going to influence how people and animals and the environment interact, how we come into contact with wild animals, how our livestock come into contact with wild animals. And climate change certainly is going to influence the likelihood, the risk of spillover as it changes the way that we come into contact with animals. And so contextualizing climate change and epidemics as really two sides of the same coin that have common drivers is on the one hand alarming, because they're going to continue to intensify over time, but it also highlights that the solutions will be common, that if we address things that drive climate change, we will also be helping to mitigate spillover and emergence of zoonotic diseases. And the question of how we start to think about the direct impacts of climate change on disease emergence is a trickier question, because spillover and emergence of zoonotic diseases, epidemics happen on a different time scale. They are stochastic events whose frequency is increasing based on the drivers I mentioned. And climate change is something that we look at in terms of trends, whether it's, monthly, weekly, annual, and decadal. So we really think about climate change as trends over bigger timescales than we do epidemics. In some ways, epidemics can happen instantly, and it's hard to really pinpoint the cause of any single outbreak on climate change, but we do start to see patterns of how climate change is influencing the likelihood of spillover and epidemics. So it would be interesting to get into that as we speak further.
Thank you very much, John. So climate change is indeed influencing many factors and has a very strong impact on zoonotic disease. And when we try to see, on what we can actually take action to prevent the emergence of zoonotic disease in a context of climate change, we look at the host, as you say, the pathogens, the contact between these ones, and vectors or intermediate hosts. And Cyril, I would like to ask, how climate change impacting differently these different actors, the host, pathogens, and vectors or intermediate host?
That's a tough question. So I'm going to focus on vector-borne diseases. So disease like infectious diseases like malaria, dengue, chikungunya, plague, blue tongue, etc., etc. So they need those three components. You need a vector, you need a component, pathogen. The vector needs to be able to transmit that particular pathogen to a host that's usually a vertebrate. But there's also disease transmitted to plants and other species. So it's quite complicated, the realm of vector-borne diseases. Temperature tends to impact most life on the planet, maybe if you accept tardigrades. If it's too cold, you die. Too warm, you die. And there's a nice range in the middle, nice niche in the middle where things can survive, more or less. So it's true for vectors as well, because those vectors are usually arthropods. They're they're hematophagous insects that feed on you just for the sake of reproduction, just for laying eggs usually. And that's how they're going to transmit disease from host to host usually. There's also a risk on transmitting those pathogens from humans to humans, but also sometimes from animals to other species. So it can be quite complicated. So temperature impacts development rates of the vectors in its aquatic life stages, in its aerial life stages with differentiated impacts. It depends also on the vectors you're looking at. Some vectors like it hot, tropical vectors. Others like it more colder. So you can also vectors living in temperate or periarctic regions. They exist too. So that's going to impact a bit their life cycles. Something that's very important too for the pathogen and the vector, the couple, is what we call the extrinsic incubation period. So that's the time for the vector to become infectious following an infected blood meal. So basically, it gets some time for the vector to be able to retransmit a disease once following a blood meal, and that time is strongly regulated by temperature. We know that because it's been tested in the lab by colleagues, so it's what we call competence experiments in the lab, and they test vectors at different temperature and count how many can become infected after a certain time frame. This is critical because if the temperature is too low, sometimes the mosquito can be around but won't be able to retransmit disease, so it can die from its natural death, like old mosquitoes age and goes. But sometimes the temperature is high enough for the mosquito to be able to retransmit the pathogen to another host. So that's a critical factor in terms of temperature-mediated impacts. Then after you got rainfall, humidity, that's going to be also very important for breeding sites. Too much rainfall can flush them out, so sometimes you got a positive impact. But then after, when the water is going to recede, you're going to have a bloom of vectors and you can have big epidemics. The example, the floods in Pakistan in 2022, when the floods receded the year after, WHO estimated that the numbers of malaria cases were multiplied by 5, more or less, just to give you an idea about these kind of impacts. Temperature, rainfall, humidity going to regulate this window of activity of the vectors, so hence potential transmission risk, and also severity of outbreaks with many other factors, as John said before, land use critical, livestock critical. There are several factors you need to factor in. Then if you talk about the host, that's very complicated there because that's us or that's also other animals. So we are currently impacted by heat wave extreme events that are favored by climate change. It's happening right now in New York, in Italy, Spain, other places of the world. We have very warm temperature. Those warm temperature can also impact on NCDs, not necessarily only infectious diseases. It can make things worse. You got heat stroke, you got renal problems. There's the example of Salvador. They got several issues with large heat. Can also impact, I think that's going to make a nice transition to the talk by Gladys, our behavior, how we behave in those things. Because when it gets hot, you might not sleep under a bed net. And if you don't sleep under a bed net, you get more exposure, you're more likely to get malaria, these kind of things. And then also impacts the whole systems, the whole health systems, as we discussed with Jan in a workshop last week. Because if you got floods, you might not be able to access the healthcare. You might not be able to access the clinics. And success put also like a big break on several other factors. So the extremes as a whole impact several aspects, infecting the host, the vector, and also the pathogen. That's my call. Temperature, rainfall, humidity got an important role. For some vectors, wind can also play a role. And also the light, because they also got their photoperiod that's going to drive them over particular daytime or nighttime activity, depending on the vector. That's more or less my point of view on the question.
Thank you, Cyril. So yeah, it's you can't basically just act on one of these actors because yeah, it's all very interconnected and so many factors that actually play a role on this on the host, the vectors and the pathogens. It's actually quite interesting what you said regarding the different environments and like some extreme environments or extreme temperature having a role on the potentially the immunity of the host. And as you said, we can have now a specific example in a specific environment. So Gladys, you've been working on gorillas protection for more than 20 years now in tropical forests in Uganda. And so talking about the host, what is the impact of climate change on these specific sensitive hosts that are gorillas, but also on their environment here? And what are the signs of climate change that you observe on gorillas, on the forest, and what are the consequences on the emerging diseases? I think you muted, Gladys. We can't hear you.
Yes. Good morning from where I am right now in Colombia at a workshop, not Uganda. Yes, I've been working with mountain gorillas for close to 30 years. And we have noticed that the climate is changing. Cyril just mentioned malaria, things like that. We find when I first went there, people weren't getting malaria, and they're now beginning to get malaria because it's warming up. It's quite a high altitude. And we found that the mountain gorillas are beginning to have a change in their ranging patterns. Normally, gorillas have a ranging pattern Each family group has a ranging pattern. When they get habituated for tourism, they tend to leave the park to forage in areas where they used to forage before gorilla tourism began and before their forest home was cut due to high human population growth. But we also think that they're going to look for other kinds of food. They like to eat the stems of bananas because there's a lot of moisture. And so that we found a lot of that. They're always going outside the park and eating the banana stems. And I think they're basically maybe not getting the food that they need inside the park, which is leading to them changing their ranging pattern and making it easier for them to do it because now they've lost their fear of people. And of course, once they go outside the park, they get into contact with humans. We have had diseases jumping from people to gorillas, such as scabies, which is a preventable disease, but in communities that have inadequate hygiene, it isn't really so preventable. And so they actually just picked it up by touching dirty clothing that people put on scarecrows, infected clothing, and got scabies. We lost a baby gorilla, and the rest could only recover with treatment. And it happened to other groups as well, another group. They also pick up intestinal parasites, through open defecation and things like that. So the fact that things are changing, the weather is changing, the weather patterns are unpredictable. It rains when it's supposed to be dry. It's dry season when it's supposed to be rainy. The dry seasons can be longer than normal. The rainy seasons are quite dramatic. All of that tends to affect the gorillas and other wildlife as well. So that's kind of what we're seeing. We haven't yet, we know that they go outside the park and it causes human-wildlife conflict. Of course, people are very unhappy when their banana plants are destroyed or things like that. But we don't know if they're also going there to look for other food that is beginning to disappear because of the impacts of climate change, which then leads to zoonotic disease spillover.
Thank you, Gladys. So yeah, it's quite different consequences that climate change have, and you have like an interconnection of these different factors that are affecting the environment, the host, the human population, and the vectors and pathogens that are here. So
yes, we do find that the gorillas in Bwindi, because there's water, when they get to a water source, they'll try and drink. If it hasn't dried up, they either put their head in the water or they put the water on their hand, and lick it off their fur. It's not really seen much in Virunga because they don't have those water sources inside. So, the whole climate change issue really affects them.
Oh, absolutely. Is there like other factors, like how, what are the other factors in this environment related to climate change, but also to disease transmission over there?
Yeah, what other factors? Well, it's very humid. It's quite humid. It's a high altitude, but then when the areas where people and gorillas mix, people go quite far up the mountain. So we have like high human population growth. We have people who have less than adequate health services and hygiene practices. So all of these factors then result in disease spillover between people and gorillas. And so because the fact that the gorillas are not on their own, they're always mixing with people either outside the park or inside the park. And with inside the park, when tourists come, to visit the gorillas, they could also spread diseases, but we make sure that they're wearing masks and they don't get too close, although that doesn't always happen. And so there is interaction inside and outside, also poachers coming in to hunt mainly other animals, not gorillas, that they like to eat, like the duiker and the bush pig. At Bwindi, people don't necessarily eat gorillas. They don't eat gorillas, but they eat other animals. But they set snares and spears, which then affect the gorillas. But when the poachers come in, you can't control that either as well.
Thank you very much, Gladys. And so we tend to think about, zoonotic disease emergence in some hotspots of emergence. So for example, we're talking here about tropical forest, and we can see all these different factors, and also this type of disease affecting mainly vulnerable populations with so many different factors and drivers of zoonotic disease emergence. But we can see also today some sort of like different patterns emerging, and I will ask you, Jan, if we go to a different location, we can see now a new pattern of emergence or re-emergence of disease and zoonotic disease in Europe. So we've seen here with Gladys some key drivers and contributors to epidemics in Uganda and within the gorilla population and the human population there. But what about in Europe? What are all the underlying reasons for, infectious disease emergence there?
Yeah, thanks, Elsa, and thanks, Catherine, for organizing this. It's great to have these different experts come to the table to discuss these issues because it's obviously so multifactorial. So it's great that we can learn from each other and discuss these type of issues. So we were interested in what leads to epidemic events in Europe, right? What are the underlying drivers of these epidemics? Because if we don't know what causes these type of outbreaks, we are just walking in the dark and we know, never going to figure out where to intervene. And so we basically didn't know what to do. And so we brought experts to the table, experts like yourself, from all over the world. And we asked them, what are the underlying drivers of epidemic events in Europe? And our experts told us that there are three categories of drivers. One is global environmental change. That obviously includes climate change, but not only environmental degradation and all that. So one is global environmental change. And then the other one is public health systems, breakdown in surveillance systems, breakdown in animal health systems, and all the public health system that contains these type of outbreaks. And then the third category was socio-demographic change, so an aging of population, and lifestyle changes like vaccine hesitancy and things like that. There are these underlying drivers of disease. And so then we combined these different drivers, sub-drivers, to cause plausible scenarios that have an impact on public health that can potentially be catastrophic. So what kind of infectious disease outbreaks that can overrun the public health infrastructure? And so we came up with these different drivers and scenarios that could be caused. Then the next thing we wanted to do, we asked the question, is this true? Because anyone can draw any scenario out of the hat, right? So we would like to know, is there any way for us to quantify this? And in order to find empirical data to examine exactly what's going on, what are these underlying drivers, we tapped into epidemic intelligence that's collected at the European CDC. So epidemic intelligence is an investigation of outbreaks that happened worldwide, so whether it's in Saudi Arabia, a respiratory disease like SARS, or whether it's a sexually transmitted infectious disease in Europe, or whatever that infectious disease outbreak will be. All these outbreaks are collected and analyzed at ECDC, and the threat to Europe is examined. And so we looked at all these epidemic events that are collected by epidemic intelligence and looked at every single outbreak and the underlying drivers that caused that particular outbreak. And so these are outbreaks that could be measles outbreak, dengue outbreak, malaria outbreaks, and we looked at all that. And guess what we found? Which one was the most important driver of infectious disease threat events in Europe that are a threat to cross-border threat to public health? It turns out that the most important driver is travel and tourism. So that was the overarching strongest driver for these type of events, followed by global trade, followed by public health system breakdown. But climate is, in fact, in the top 5. And what we saw is that these outbreaks are rarely, if ever, caused by one driver alone. It's always multifactorial. As John pointed out earlier, climate change interacts with land use changes and our food systems, and that contributes to these type of outbreaks. And obviously, zoonotic diseases is particularly susceptible to climate change because a lot of zoonotic diseases are transmitted by invertebrate hosts, vectors that Cyril spoke about so eloquently, and they are going through an environmental compartment that's susceptible to climate, and that's why they're climate sensitive. So zoonotic diseases in particular are very sensitive to climate, but overall, the strongest factor is travel and tourism when it comes to epidemic events in Europe.
Thank you, Jan. And so actually, just to follow up on that, and how climate change, and it's kind of an open question, how climate change can impact these other drivers. So you're talking about tourism and mobility. We've been talking about land use. So how is climate change having an effect on these other drivers? What's the, like on human movement, for example, on host movement, for example?
Yeah, so we looked at population movement. So we looked at passenger volume of people coming into Europe from tropical areas. And we see that a lot of people coming from dengue endemic areas or chikungunya endemic areas, they're coming into Marseille, into Paris, or into Rome, areas where we have local mosquitoes that can potentially transmit these type of viral tropical diseases. And so once these people come in, they might have a virus that they picked up in the tropics, and then they get bitten by a local mosquito, and we have a local outbreak. We call this autochthonous transmission, where you have local transmission chains where viremic patients are coming in from endemic areas, they're getting bitten by a mosquito, and because the climate is so conducive to transmission, we see this type of outbreak. And if you look at dengue outbreaks in Europe, we can see that there is an exponential increase in these type of number of cases of dengue that we see in Europe. And when we see the districts that are impacted, we see more and more districts that are impacted by that. So climate is a strong contributor to these type of outbreaks. But again, it's not only climate, right? So it's importation risk, which is the population mobility part, and then the climatic suitability that increases the risk for transmission. So it's always a combination of factors, as John pointed out so nicely.
And I actually wanted to jump in on something Jan's talking about, because it's really interesting when we look at climate matching. So there's climate change, but then there are also parts of the world that tend to align climatically at different times of year, seasonally. So with human travel that can happen seasonally as well, there are times of year when Europe or the United States might more climatically resemble the tropics in our summertime. And so that's a particularly higher risk time when people come back and might introduce pathogens, where local mosquito populations will be present and more active, as opposed to, say, in our winter when mosquitoes aren't present. So even the timing within a year can influence the introduction and autochthonous transmission of pathogens. And with climate change, those overlaps are going to increase. We're going to start to resemble the tropics even more and allow for a broader window of introduction through travel.
Absolutely. Thank you, John. Actually, so I can go, it's a perfect introduction for my next question, where we're talking, so we've been focusing a little bit on Europe here with Jan, and so my question is, what's the impact worldwide? Like, I would say, for example, Cyril, with the vector ecology and the changes in vectors niche, but also in different environment, we've been seeing that forest is a very sensitive and specific environment for climate change, but also aquatic environment, for example. And what's the impact worldwide?
That's a very difficult question. There's a lot of disease you can talk about,
yeah,
to get back,
you can have you can focus on few examples.
A few examples on vector-borne disease, but first I want to rebound on what's been said by Jan. I mean, it's not new that we've been moving disease. The Black Plague in the Middle Ages was imported by Italian ships leaving the Crimean War, I think, and introduced in Sicily, and that's how it spread. And we think killed the third half of the Europeans at the time. So we've always been moving things around. We've always been moving yellow fever mosquitoes around. We've been moving rats and their fleas around. So it's not new. And people have been doing that in all sorts of different parts of the world with their own environment. So that's very important for sure. So we move the vectors in the first instance, and also the potential hosts, so our intermediate hosts sometimes for those vectors or those pathogens. But back to the question, if I want to make it relatively simple, there's some kind of consensus for some of the vector-borne diseases that they're moving, at least the vector. It's not necessarily more complicated when you're talking about incidents and cases. But things are moving up in altitude, and Gladys made that point in Uganda, and also what colleagues in Rwanda has been telling me in Muzanze, which is also not far from a gorilla protection area. They start having some cases never had before. Human malaria, they're usually more in the south, in the warm-up part of the country. And we start to see those things moving up in different parts of the world. You see that for some Anopheles mosquitoes in Africa. You see that for some ticks in the Carpathians, in Switzerland. So up in altitude, but also up a bit in latitude, with some tick species moving into Canada, Maine of America, down to Argentina, Uruguay down, then in South America. So things on the fringes are moving, things in altitude are moving, but it's not necessarily only climate, it's also because we move things around. So it's a mix of both. And we can kind of see those trends at the minute. We saw dengue, Aedes mosquitoes transmitting arboviruses moving up in Europe, that's quite clear. Ticks also moving up into Scandinavia, but they might suffer from the heat also in the southern part of Europe because they got different preferences. So it's not only, yes, an important point there I want to make is that when it gets hot, they also suffer. So some species might also be wiped out and disappear because of climate change, not because climate change that everything's going to get worse. In some places, it might kill the vectors, we hence make the problem disappear. It might cause other problems on other sectors. But anyway, so that's more or less a trend that we tend to see on vector-borne diseases. You can see it some waterborne diseases. There's some colleagues working on cholera, Vibrio vulnificus also, and see some signals in the future moving up in the Baltic Sea. And the Scandinavian colleagues are worried about that. You got also things happening in the sea, in the marine environment, with algal bloom that you see more often getting there. So it's not only on land, it's also in the sea, and also on the coasts. That's more or less the trend. But in terms of incidence, it depends where you are. In the West, the Western wealthy countries, NCDs are the big problem, and then those infectious diseases are a bit a lower issue. But a bigger issue in the tropics and the global south overall. And they climb. Dengue is skyrocketing. It's a problem everywhere now. And it's getting worse and worse.
And so it's getting worse and worse. But can you also see, for example, some environments becoming unsuitable for some vectors, for example?
Yeah. There's some. It's not. It's not unprecedented. There's been field entomologists in the past that show that, for example, in the Sahel, there was a terrible drought in the 80s and 80s that basically caused a lot of problems in terms of famine, loss of livestock, etc. It was a big drought, historical drought in West Africa over those years. And during that period, some field entomologists show that the vectors population were crashing in some parts. Even if sometimes the malaria cases was counterintuitive, were going up in some places because of crowding and because also there's like small hotspots of mosquitoes in specific zones. So this is not unprecedented. There's been some historical examples of long drought or long changes in the environment leading to disappearance of a particular vector or particular disease. And we could expect in the future that I'm sorry, some of those very simple models. We tend to see those kind of shift in Africa. For example, the risk seems to be climbing up in altitude over the middle fringes for malaria, while in the West, if you just take into account the very warm scenarios into the future, the risk might be going down because temperature start to kill the Anopheles in our models. So there's a lot of uncertainty there. You have to be very careful. But that's what the model tends to suggest overall. There's a shift towards new zones as a background. And I would say the climate set up some kind of background for those climate-sensitive diseases. But for others, the land use and livestock might have a far bigger impact, obviously.
So, I mean,
thank you, Cyril. Yep.
So there definitely is some examples like that. Chikungunya, for example, we project that will contract around the Adriatic coast around Italy because of climatic suitability is suboptimal. And we see a contraction of transmission. However, that tends to be the exception rather than the rule in general. So as part of the Lancet countdown, we compute climatic suitability in a historic time period and compare that to more recent time period. And then you can see how that climatic suitability for vector-borne diseases, but a lot of other diseases also changes over time. And in general, we do see an increase in climatic suitability worldwide for malaria, for dengue, for chikungunya, for West Nile, and the Vibrio infections that Cyril mentioned. So these are waterborne diseases that love brackish water, so water with low salt content. But it turns out that they're extremely dangerous if someone goes into the water with a wound, because you can get a wound infection that then can potentially get infected that requires amputation or potentially causes death. And so we definitely see an increase in the climatic suitability for these waterborne diseases also. So we do see some contraction in certain areas for certain diseases, but in general, we see a general increase in many of these infectious diseases throughout the world.
Yeah, and when we talk about vector
Thank you.
shifts too, it's a compounded risk, because not only do we think about expansion of range of different vectors, but when that happens, it might mean bringing pathogens we know about to new populations that are more naive immunologically. We saw what happened when Zika was introduced to the Americas, and this was a population that hadn't experienced it before. So not only was the vector present, but you had a more susceptible population that allowed it to spread like wildfire. So it's a matter of vectors expanding their range and introducing pathogens to new susceptible or naive human or animal populations. And then similarly, also having vectors now perhaps exposed to wildlife that they might not have been interacting with before, which could potentially introduce even new pathogens into new populations of people.
That's something, it's a good example that Gladys presented earlier with gorillas and other type of wildlife where hosts are being affected by new viruses, new pathogens that they were really a naive population, which can cause increased damage. So moving from vectors to host, actually. So we've seen a very good example from Gladys, but John, could you actually tell us a bit more about these changes in host ranges in pathogens, geographical distribution, and what are the consequences in terms of evolution of viral spillover or pathogen spillover in general? We don't. So with this host movement there.
Yeah, right. I mean, it's the other part of it is, I think the vector range expansion is probably better understood and studied in terms of, there's a lot of good data and research going on to understand the home range of different vectors. Host movement, particularly mammalian movement, is a little more challenging. I mean, I think there's a lot of consensus that as environmental suitability changes, animals, just like people, are going to shift and move to adapt. And it's both a matter of climatic suitability, but animals are also driven by food resource availability. So climate change will impact vegetation and fruiting and flowering patterns. And so animals that are dependent on, nectar or fruit or vegetation are going to have to move and shift to find food availability. And so when we think about hosts for zoonotic pathogens, we tend to think about, two groups of mammals that are among the most abundant, rodents and bats, and they also tend to be mobile. And what they also have in common, rodents and bats, is that they live everywhere people live, and they're very well adapted to humanized environments. And so not only do we anticipate shifts in wildlife ranges, but also a hedge that wildlife have is that when they live around people, they often have access to food resources. This concept of wildlife provisioning, where people tend to provide food, whether it's intensified, cultivated fruit, or whether it's just food waste or, urbanized environments that provide lots of food and shelter for animals. So the species that tend to do well around people are going to be able to adapt to climate change probably better, because they might lose some natural forage, but able to replace that with human provided forage. So our relationship with wildlife will intensify. And there have been some good predictions or models that look at potential biodiversity shifts and how that might influence pathogen spillover. So, the physical movement of animals and interaction with people will certainly directly influence the likelihood of us getting exposed to animal pathogens. But what we also anticipate happening is that biodiversity shifts as species of rodents and bats, just for example, but really any animals, birds included, as they start to interact with new other populations and new species, there's going to be viral exchange. And I'm just going to focus on viruses because those tend to be the pathogens that lead to broader epidemics and pandemics. But viral evolution will be driven by new host-host interactions, new species interacting that have the opportunity to get exposed to each other's viruses that will drive evolution. And for those viruses already predisposed to being able to jump hosts and infect multiple different hosts, then there's the opportunity for new viruses to emerge, but also for viruses to get into human populations through increased contact. So there was a good study put out by Colin Carlson's group predicting that looking at climate models over the next 50 years and looking at the anticipated biodiversity shifts, the places where we're going to see the most intensive new host mingling, that's new mammalian species interacting with mammalian species, is going to coincide with populous areas, human population densities. And so not only are the hotspots of viral evolution going to intensify with climate change, it's going to happen where people are. So we anticipate seeing even more spillover emergence that way. So it's tough to measure, but we have to stay really on top of understanding and anticipating these host shifts, because it's going to lead to more contact with livestock and people and more spillover. And then the last point I wanted to make is that sometimes biodiversity shift can impact climate change too. When we think about ocean temperature warmings and how that influences things like phytoplankton and carbon cycles and CO2, sometimes these biodiversity shifts are going to have influence over temperatures and climate change unto themselves. So it's a really dynamic process, but I think there's growing consensus that we have to stay on top of it in terms of surveillance. We have to continue to pay attention to what's happening in wildlife reservoirs because it's so dynamic, so that we get ahead of, these viruses being able to emerge, looking at how people are going to interact with wildlife under different climate scenarios.
Yeah. It's talking about people interacting with wildlife. It's particularly interesting. And actually, I can go back to you, Gladys. You mentioned earlier many different factors and drivers of zoonotic disease emergence in the forest environment. And I would like to ask you, how is climate change impacting the other drivers? And in your opinion, what do you think is the most important driver when it comes to, human and wildlife contact?
I would say there's lots of drivers, but a lot of it is, when people are hungry, they'll tend to want to enter the park. And what makes them hungry? Again, the impacts of climate change. We introduced fast-growing food crops to reduce people's dependence on the park, especially during the pandemic, when no money was coming in from tourism. And some of it worked, but then floods came along and washed away some of the vegetables. So then when people are hungry, they tend to enter the park. And they'll tell you that's the main reason people are poaching. We distributed questionnaires to over 1,000 people. The first 1,000 households we targeted, and majority said that people are poaching because they're hungry. So then that ends up driving them into the park, and there's greater interaction between people and wildlife. So what we're trying to do again is find those kind of crops that are less, that are more resilient, less impacted by climate, to make sure that they can plant those crops in their gardens and they don't have to enter the park, providing enough nutrition and a food source that prevents them having to interact with wildlife. And getting in contact with bushmeat, zoonotic disease goes in both directions.
Such an important factor.
Other drivers I would say is, other drivers that lead that climate change, other areas that we're trying to help the communities is obviously through behavior change communication. We're trying to make sure that they're more healthy and hygienic. And so we have this One Health model where we have community health workers who are trained to do conservation work, and they touch all those important topics, including having hand washing stations, no open defecation, having a pit latrine, all those kind of things. So again, there's less disease spread between people, wildlife, and livestock when people are not openly defecating. And, the livestock, we try and help the farmers to dip cattle water troughs so that they're not defecating in the water sources that people and gorillas are using. So we try and do a lot of those kind of things. But yes, water sources are also areas that can be a big spread of disease. And when they dry up, because of the warming climate, there's greater concentration of all kinds of pathogens in the water. So yeah, these are all kind of drivers. But the more that there's a high human population growth, high human population densities where wildlife is, then again, that there's going to be a greater human-wildlife interaction, as John was saying. And once you increase that interface between people and wildlife, there will be more disease spread between people and wildlife, livestock and wildlife, and people. And therefore, you really need an approach that looks at all three to address it more holistically.
It's what you're presenting is tricky because it's quite of a vicious circle. You said tourism can be a factor of disease emergence and increased contact rate between humans that are not always wearing suitable protection. But in the absence of tourism that is bringing financial resources to the local population, then they will go into the forest and then, also increasing animal-human contact rates. So quite a vicious circle there. And what you're presenting here is, so we can see that these zoonoses are mainly affecting vulnerable populations. So how can we work with these communities? You've been talking about, like trying to some sort of like education and support for like reducing open defecation or other factors like this. But how can we work with the most affected population, the most vulnerable population that are really affected by climate change and zoonotic disease emergence to prevent and mitigate the risk, Gladys?
Yeah, we do work with those most vulnerable populations, the ones who tend to live right at the edge of the park, and they see the park as a source of food. They're very reliant on the park for natural resources. So we work closely with them, and actually we go beyond education. It's more like behavior change, communication, which we've learned how to do, working with public health stakeholders who are very good at behavior change communication compared to conservationists. And generally, we try and get them to have a household that can cope in such situations. So we call it a model household. And we have like 12 ideal indicators where we get them to have at least 9 out of 12 ideal indicators. Amongst these are hygiene and sanitation indicators. Amongst them are having a food crop garden, that has enough food, but it's done sustainably, sustainable agriculture. Having potentially planting trees. We get them to plant trees in their homesteads so that they don't have to enter the forest for firewood. We also get them to, we talk about knowledge of human and wildlife disease transmission and how to prevent it. We try and make sure that their knowledge really goes up, because then they can find different ways of preventing it. They also we also try and make sure that we try and encourage them to have an alternative source of income, like a cash crop, like coffee or tea, or it could be employment or livestock, but then the livestock have to be in a separate animal shelter from the people. So we try and do a lot of that, because we feel that if the more model households we have around the park, the less need there is to have people entering the park. And even if animals go into their gardens, like gorillas, baboons, or other wildlife, they're less likely to pick up diseases, and they're less likely to be less disease spillover between the people and the wildlife. And over time, we've seen in the past 3 years, the number of green households have increased from 23%, the ideal households, from 23% to 61%, and they're really proud about themselves. So we're trying to just keep spreading this model all over the forest, and we're trying to correlate it with reduction in disease transmission at the human-wildlife livestock interface, and also illegal entries into the park, poaching, and things like that, working closely with the Uganda Wildlife Authority and the other government authorities, the Ministry of Health, the Ministry of Agriculture, the veterinary officers, the livestock vets around the park. So yeah, those are the kind of ways that we're trying to get communities to lead. And the people who educate them is volunteers from their own community.
Yeah.
The village health and conservation team. So they're basically community health workers doing conservation work. They lead the efforts. We train them to lead the efforts, because they're more likely to convince a fellow community member to change if they're from the same village.
Yeah, it definitely makes interventions more sustainable and more acceptable, of course. Yeah. So you can see that sustainable income, sustainable resources will definitely help on that. And so agriculture can actually be a way of having this sustainable income, but we know that agriculture is particularly impacted by climate change. And I would like to ask you, so in terms of, so we've seen these other drivers and the impact, for example, of climate change on agriculture that can then lead to human movement, population movement, and in particular vulnerable populations. So what can how can we work with these population that will have to move to prevent and mitigate the risks?
Yes.
So I fully agree with what Gladys said. The community engagement is essential, and we can't get around that. There's no early warning system that works with out community involvement. The way that we have been working is like we tackle this problem from three different angles. The first thing is we need to set up surveillance systems that are appropriate, that capture some of these events. So we want to monitor climate-sensitive infectious diseases and see to it that we have appropriate surveillance systems that capture those. And we particularly are interested in those surveillance on those infectious diseases that have a high disease burden. So that's the first thing that we need to do. Then the other thing is that we would like to link the kind of surveillance systems with environmental data, climatic data, basically integrated surveillance. And I call this a continuum of surveillance, where we move from human health to animal health to environmental health and connect the three, because this is the One Health approach that is broken, that doesn't work. We need to make sure that human health is connected with animal and environmental health in order to make sense. We need to be able to monitor epidemic precursors of disease, climatic signals that can indicate that something is going on, because that's the backbone of these early warning systems. And we have set up the only operational early warning systems in Europe for infectious disease for Vibrio infections, where we monitor sea surface temperature and salinity to see which beaches are at increased risk for these type of infections. And then the third category, and this is where Gladys' work comes in, we do a lot of citizen science, where we engage communities to help us conduct entomological surveillance. So which kind of ticks have been picked up? What kind of mosquitoes have been picked up? Do we see invasive species? And then link this type of entomological data with human health data. We collect data about animal-human interface, so people can report where they saw a roadkill or a sick animal and all that. And then we use these type of data for our modeling efforts, and we can see that these type of data are essential to get a handle on these type of zoonotic diseases. We need to know where humans interact with animals in order to get a handle on the risk. So those are the three categories: the surveillance systems for climate-sensitive infectious diseases, the early warning systems, and then, as Gladys pointed out, this engaging communities in the whole process, and particularly citizen science, get the expertise from the communities to see where those interactions of animals and humans are potentially an issue for the zoonotic disease transmission.
Yeah, and I'm so
Thank
glad
you.
you brought up monitoring and
Yeah.
surveillance. I'm sorry, I want to jump in this.
No, go ahead. I was going to ask you something, so it's fine.
but because when we think about spillover and we think about risk, one of the big black boxes that exists right now is we actually don't understand how frequently spillover of zoonotic pathogens happen. We tend to notice when there are big epidemics, we wait for clinical cases, but those are the things that we notice, but we don't know what the denominator is. We don't know how often people have been exposed to pathogens in animals, and maybe it doesn't result in an epidemic, or maybe, the exposure rates are minimal. And if we're going to think about interventions, if we're going to target areas where we know there's high interfaces between people and wildlife, such as communities living on forest edges who utilize forest, we have to have some understanding of how frequently they're exposed. And if we're going to set up interventions, whether they're behavioral or educational or environmental, we need a baseline by which to measure the efficacy of those interventions. So Jan, I just wanted to say that I think that surveillance and monitoring in a broad sense is so important, but also looking at exposure rates, trying to figure out ways where we can understand when spillover happens and under what circumstances, even if it doesn't result in overt clinical disease, which is challenging, but it's something that we're missing right now. Sorry, Elsa, back to you.
No, thank you, John. That's absolutely fine. That was actually a question for you and Cyril regarding. So we've seen that different drivers, more or less impacted by climate change, are affecting different population. And my question was to you too also. So are affecting different populations, different communities. How can we work with these communities, depending on the drivers of zoonotic disease emergence, the local drivers, I would say, and how climate change is actually, I would say, strengthening the impact of this driver and the consequences of these different drivers.
Cyril, do you want to begin?
Cyril, do you want to,
that's
to jump in?
That's a very broad question, but I think it's been answered a bit by Gladys and what John just said before, and also Jan. I think what you need, in practice, we frame that with my colleagues at the IPCC, whoever you communicate to, from your president down to a villager, there's always 3 layers: language, values, and power, the power structure. And you need to make sure that you got someone who's been working, who's got the trust of the community or whoever audience you're in, can be understood with the local language or the local dialect or the jargons as well, because we speak about multidisciplinary science. But that's quite sometimes the people don't understand us. They look at us like aliens. They don't understand the words. They don't understand the jargon. So you have to make sure that you got those champions at the interface. I think Gladys is one. So it can be veterinarians. You got people also doing activists, can be champions sometimes. You got field ecologists, could do that job too. Anthropologists and social scientists, also very important to get also the feedback and get the framing right with the communities and the stakeholders. So that's how you do basically good science, when you manage to do your science, interact with the right stakeholders or communities or who you're trying to work with, and make sure things, like Gladys said, things need to keep on going later on. Like if you just go say, okay, we got a project, you finish, you're gone, and then things might stop a year later, and all the energy you've been spending, all the money just goes into smoke, basically. So that's a critical point, I think. For the keep going thing, for the drivers and how they impact the communities, is more about, I'm not really sure. Can you?
Well, my question is, we have different drivers that are differently impacting local communities. So like, how do you work with the communities with a specific driver, in the context of climate change? So but this is what you say. Basically, you rely, and this is so what Gladys has been presenting, and also some echo from our previous webinar on equity issues. You need to have sustainable intervention. You need to have acceptable intervention. And the people that will lead these interventions are really important. I mean, you can't do anything without this bottom-up approach and really taking into account local perspective, local knowledge, and local acceptability.
So local values, I would say, also.
Absolutely.
So what's your values, what's your culture, and you have to be very respectful and make sure things work on a trust long-term relationship. No, I fully agree.
And this is what early warning systems are particularly important, because they rely on these local stakeholders over there usually.
There was a really interesting study out of Stanford University that was done over a 10-year period in Indonesia, looking at communities living on the forest edge who relied on timber harvesting, whether, illegal timber harvesting, going into the forest illegally for subsistence purposes. And they found that the number one thing that helped to reduce that activity was actually health security. So this is something we haven't talked about yet, but in addition to, information and education, just providing basic health services to communities, giving them health security, was very significant in the reduction of illegal timber harvesting in this particular study. And I thought that was so interesting because, health security is one of the biggest, or I should say health insecurity is one of the biggest things people experience, and climate change is only going to increase that, amplify that. And so while we work to, mitigate at global levels, climate change, the impacts felt at community level are going to be intense. But where governments can have big impact is stepping in, providing health services and security to these populations. And that can help reduce behaviors that lead to spillover and disease emergence. So there's a really strong connection there.
Yeah.
Thank you. Thank you very much.
Health in Harmony. They have a very
Health in Harmony study. Yeah, it's fantastic.
started by a medical doctor. Yeah.
So we talked about communication, but I have a question, and that is needed like a sort of very brief answer from each one of you. But it's, in a context where climate change is inevitable. I mean, we can take actions, and actions are already being taken, but we know that this is not going to change global warming within the next few years. So how can we, in this context, how can we prevent zoonotic disease emergence? I would say, what should be the priority in your opinion? I don't know, Gladys.
Is this as far as communication goes, or just in general?
It can be, well, I would say, how can we differentially communicate, but not only communication, is like, what should be the priority in this context of inevitable climate change to prevent zoonotic disease emergence?
Yeah, I think the priority should be helping people to adapt, climate change adaptation measures, making sure that their health and well-being improves, that, if they're planting crops, they're planting climate-resistant crops. For example, we found that even among coffee varieties, we support coffee farmers around the park with guerrilla conservation coffee. We find that sometimes the agriculture people are telling you that these crops are affected, like Arabica is affected by climate. But, there has to be a huge multidisciplinary effort everywhere in order to work with all the different sectors in order to address this issue, because it's an issue that affects all sectors. It's not just the wildlife sector or the health sector, but it affects agriculture and, so many other sectors, including travel. So there has to be a huge multidisciplinary effort, and all the communication needs to be multidisciplinary as well. There's nothing wrong with talking to tourists about health issues, and talking to communities about, like zoonotic disease, people just need to understand that how they can help themselves to be more resilient in all of what is happening at whatever level it is. So I think a multidisciplinary effort is really important everywhere. Actually, we've been able to reach about over 50,000 people just through behavior change communication, working with 430 volunteers in one national park, Bwindi, but we're also scaling up to savanna parks and other kind of protected areas. And everyone has a different way of being reached. Communities like to in-person contact, maybe radio, but of course, social media reaches everybody beyond a certain age, the young generation, and as a lot of policymakers still go to things like X, Twitter, others LinkedIn. You just have to find people where you think you're going to find them. Even if you have to use TikTok, then you go to TikTok.
Yeah, I think that's something, Cyril, you mentioned also previously, like using influencers to do a job that us scientists are not always the best, the best to do.
Yes, Instagram for the younger generation, Facebook, whatever.
Yeah.
It's just we need to kind of think how we're going to reach the people we're going to reach. But in Uganda, and I think around the world, we typically find that people still like Twitter, or X now as it's called, because it's just good for policymakers, like leaders who can make change still refer to Twitter. So you still have to use it whether you like it or not. Like if you want to reach out to people. And it's a platform where people don't necessarily always agree, but it's that debate that gets people to understand more about what's happening. You saw during the COVID pandemic, all the things that are happening around COVID and still are, it's just a way to get more and more people involved. And as scientists, we need to reach out of our bubble and reach people in all kinds of sectors, including the politicians, and just, the people we don't normally work with, but to reach all those kind of people.
Thank you, Gladys. So Ian, I will ask actually the same question. In this context of inevitable climate change, how can we better prevent zoonotic disease emergence? How can we still act when this important driver will still be there?
Yeah, so thanks for that. I totally endorse what Gladys just said about this multi-sectorial approach of reaching out to the community. There's something that I called lateral public health, because we in public health, we have been extremely effective of having these vertical programs to eradicate smallpox, eliminate polio, or going after one single disease. The problem is that the current world that we live in is so much more complex and contextual, and there are so many overarching interacting factors that you can't just go after one individual disease, right? If you eliminate polio out of a community, your child might die from a respiratory disease because you don't address the poverty that underlies that. So I call these lateral public health, where we get outside the box, and just like Gladys said, we need to connect with different sectors in community. We need to get the faith-based community involved. We need to get the business community involved. We need to get agriculture, security. Everybody has to be at the table to discuss these type of issues in order to increase climate resilience, because there is no climate resilience in communities unless you get them engaged and train them in disaster preparedness, early warning systems, and response. They have to be at the table. So it's essential, as Gladys points out, to make sure that we break out of our box that we live in public health, and break out to the different sectors in society, and most importantly, engage the community from the very beginning. Community-based participatory activities, research, and get them engaged in these type of activities. Otherwise, it's just not going to work.
Yeah, no. Cyril, do you want to comment on that?
I don't know. I think Jan will be more qualified on that, but I fully agree about the multidisciplinary issue. I've been in it. I mean, I was a physicist and I became an epidemiologist, and I've been working with veterinarians, clinicians, public health people, statisticians. So it's a big, broad range of people, and I learn a lot. You learn a lot by talking to those people. So I fully agree. Maybe I can bounce on that point. There's a need, I think, from my African colleagues and elsewhere, from also new curriculum, new education, because the education is always also taught in silos. You go to your public health school, you go to your law school, you go to your agro-meteo school, whatever they are, different boxes. But I think there's a big demand from my African colleagues about this kind of new curriculum that would train the next generation of scientists to be more multidisciplinary aware, let's say, which is quite tricky because it takes time to learn all those things. It's not that straightforward. So I would say education connects to also that part, how we design the scientists of tomorrow who would have to cope with those problems, basically. That's going to be very important. And B, for communication, I was talking about influences. Yeah, that's kind of sad to see that sometimes you get two clowns putting themselves in a big box at 50C. They got millions of views, and everybody's like, "Oh yeah, by 50 degrees, you look like you're gonna die, guys, after an hour or two." And then they got millions of views, and you compare your own National Research Center, they got like 100 views on the video. So it's so I think we can use perhaps social media. I think that this is right in a right way, though. You want to avoid misinformation. You try to be the most correct you can, we will say. Give good information and good materials. You have to be extremely careful on the internet nowadays. But I think that would be also something we need to think about in terms of communication, because we're not necessarily the best, we're just scientists. Sometimes we're very quirky. We talk about our models and we got our jargons, and people could better at that. And the young generation is actually very good at this. It's back to John, I think.
We
Yeah.
And
could have
John,
a
you
whole
will have
webinar on how to better
word
connect with the public. Yeah. This
at
is
the end. So so that's my question, and a follow-up question on that. So first, same thing is in this context of inevitable climate change, how do you prevent zoonotic disease emergence? Or if you can't prevent, what do you do? And so second question is, so we've been talking about all the interconnection between these different drivers. How do you, following on that, how do you create these synergies between the different agendas on acting on these different drivers that are related to climate change? So two-step questions.
Yeah, it's important to contextualize for all the measures we have to monitor and respond to disease emergence. The real true preventative action is preventing spillover, understanding what we're doing that brings us into closer contact with wildlife, with vectors, that's going to lead to exposure to zoonotic pathogens, and working really at that point. And it's something we have to orient not just the global health community, but policymakers towards. And I hope that our education efforts, One Health is really gained traction in a nice way, both in universities at education level. It's starting to at international policy level, but I hope it extends to law schools and business schools as well, because probably one of our biggest challenges is trying to balance the financial incentives of agricultural expansion, where governments are clearing land, one of the biggest drivers of both disease emergence and climate change. But we really have to control how we are clearing forest, clearing land for agricultural purposes, which is creating more risk for spillover, more risk for climate change, and exacerbating all of these issues we're talking about. And so until there's political will, until there's an understanding at that level that there are real long-term hazards with the way we're doing business globally, it's going to be very hard at community level to adapt and mitigate to spillover risk and climate change. So everything that's been mentioned, by Jan and Gladys and Cyril is right on. We got to work at community levels, and we have to build more trust between the scientific community and the population at large. But we have to work on policy as well, because that's a major driver for a lot of this.
Thank you very much, John. And I have one final question. So, John, I know that you've been involved a little bit, and Cyril also in PREZODE. Gladys, I know that you are involved, for example, in another initiative, One Forest Vision. How can this, and well, I'm naming these two, but there are many other initiatives in the with the focusing either, as we say, on forest conservation or zoonotic disease emergence or water environment protection. How can these initiative? So I ask you a little bit, John, but can help to synchronize research between all these different topics, all these different themes, and create synergies to act against climate change, zoonotic disease emergence, biodiversity loss, agricultural practices, all these different factors. How can initiative of these types or other initiatives better help that?
To do this work, you need funding and you need resources. And what we've unfortunately seen on the United States side is a total abdication of responsibility to support research and understanding of these important relationships we're talking about today between environment and our health. And so these initiatives like PREZODE and others that are coming out of Europe and other countries are so critical because we have to do the science. We have to build an evidence base for understanding the drivers of climate change and disease emergence, for understanding these connections so that we can make evidence-based decisions. That's really the key here. So these initiatives that allow for a multidisciplinary approach, provide for this more systems thinking when it comes to health and the environment are just so critical. We need more of them and we have to expand them.
Thank you, John. I don't know, Cyril, yeah,
Yes,
Gladys, if you want to complement.
I mean, one thing we do with the Lancet Countdown is the fact that we produce a lot of data that we produce just before the COP to provide to the policymakers so we can quantify how many people die from heat-related mortality and how many people get sick, how many people are at risk for West Nile fever, dengue, and all these indicators. So one big contributor to this field is this development of indicators where you can quantify the impact and show the trajectory where we're going, because ultimately the policymakers need to know what the implications are and what we're talking about. So this is what's going to happen if we stay on track with a fossil fuel scenario, that it's going to increase and exacerbate the current conditions. And this, you can see this kind of an impact as a result of staying the course of a high fossil fuel economy. So as part of the Lancet Countdown, we are trying to quantify these effects to provide policy briefs to policymakers worldwide during COP, and then hope and push for change. So we will create a future where we can minimize these type of impacts.
Yes, and
Gladys.
just to add on to what Jan and John have said, when all these different, it enables more multidisciplinary looking at things from different perspectives, it is an issue that is affecting all the kind of sectors, but it allows multidisciplinary partnerships and collaborations. And it's also more convincing, I think, to the policymakers and the politicians when they see that different groups have all contributed to this. It's not just one science, but different sectors have contributed. But it also allows for joint fundraising, because in this current fundraising climate, which is getting more difficult, especially for research, I think these collaborations can help to raise more funds if we work closer together, and then address these issues better. But yeah, there's a call for more collaboration, south to south, north to south, as well. Collaborations, I think, would be very important in the near future.
Exactly. If I
Yes, please.
Just add something. So we were with Jan talking about the SSP scenario framework in Vienna the past few days. And I want to remind you about the SSP3 scenario. So the point, just come back to what John said about funding, capacity, building, etc. So SSP3 is basically a world that's characterized by regional rivalry, a fragmented global economy, slower economic growth, higher inequalities, and challenges in achieving sustainability goals, like some regional conflicts, etc., etc. So just want to look at the world we've been living over the past few years. USA, you got like some streams. So we need to think about that, because if we get to that path, we're going to need initiatives like PREZODE and others. And as Gladys said, it can be all directions, south-south, Brazil, Africa, China, Africa, whatever directions, but it means the more the better, really, all directions, trying to do the best science we can to prevent those problems, because otherwise we're going to end up in this utopic world that I don't want to see really, because I might be old and I don't want to live that world. So hopefully not. I don't want to retire in that world. That'd be nice. That's basically my last call. Sorry.
Thank you. Thank you very much, Cyril. Well, thank you all very much for this such insightful and fruitful discussion. We have 10 minutes for some questions from the audience. We have quite a few questions from the chat. We won't be able to take them all, but and we won't be able to address each specific example that people have been mentioning. So we have examples from outbreaks in Bangladesh, but also in Colombia. And one question, but we already be talking a lot about community engagement. So do you have anything that you could add in terms of the best fruitful and effective way to raise awareness among community, but also to enhance community engagement, or to also help people that are the most infected? For example, so they're talking about poachers and bushmeat eaters in Uganda, or community affected by Nipah virus outbreak in Bangladesh, and so raise awareness among them, but also chikungunya disease outbreak in Indonesia. So and people are asking, how can we enhance awareness, community engagement, and help people as much as possible? So we talked about that already, but I don't know if you have any other points to add for these questions.
I can start in here just because I've had a lot of experience working in Bangladesh, and I think it's a good example. I mean, number one, when countries experience repeated outbreaks of zoonotic disease that impact people and livestock and involve wildlife, it sets a very personal and direct experience that can guide policy. It forces policymakers to really pay attention to these issues. So that's a good start. But one thing Bangladesh in particular did a while ago was formally codify a One Health approach into how they think about zoonotic disease. And so back in 2013, they established a One Health Secretariat, which formally created relationships between human and livestock and wildlife sectors and civil society. So this is the important part. Community stakeholders, industry stakeholders are at the table along with policymakers to think about things like zoonoses that are going to impact poultry, if we're talking about H5N1 avian influenza, or Nipah virus, where it involves a wildlife reservoir directly interacting with people at community level and causing high mortality disease. So there are many governments now who have done this or taking this approach at policy level. And I think it's really effective because, number one, it validates this more holistic approach. But number two, it provides a mechanism for approaching diseases from various disciplines and sectors, formally an outbreak response and research. And so having it at policy level, I think, is a really important part of this puzzle in terms of addressing these complex systems.
It's actually quite interesting that you're mentioning that, because it's also goes back to other questions where, so you're talking about policies, and how do you do that when governments are not stepping in to provide the security, where in the current geopolitical context, I think we have to also to mention it, where these type of policies will are undergoing, like, a lot of changes and budget cuts and all these things. How do you carry on this work?
Yeah, as we mentioned earlier, community engagement is essential, and there are some great examples how communities have engaged in the transmission pathway of these diseases. One example is a randomized control trial that was done by Eva Harris and colleagues in Nicaragua, where they engaged the communities about the dengue prevention and vector control, and just the educational process to teach people that these little worms that swim in the water, that they actually become mosquitoes, and it's important to eliminate the breeding grounds for mosquitoes and make sure that you have proper vector control around houses where people live. That can dramatically decrease the dengue burden in communities, as it was documented by the randomized control trial. Another randomized control trial that was done for schistosomiasis in Africa was looking at how to get in community involved to eliminate seaweed in the lakes where the snails live that transmit schistosomiasis, and intervening on the environment with the community can decrease the disease burden from schistosomiasis. So again, the essential part is the community. I call this again lateral public health, where the community has to be at the table in order to participate in this type of public health solutions to reduce the disease burden. Because if they're not involved, nothing is going to work. It's the essential component of effective public health.
Thank you, Jan.
think,
So that's definitely true, and thank you, Gladys. But so I'll give you the floor in 1 second. So community engagement, and when governments are stepping down, how do you carry on this work? Can you maintain community engagement and awareness and support these communities when even when governments stop being involved, or when you have such important cutting in the financial resources?
Yeah, just to continue that part of the conversation, just like Bangladesh set up the One Health Secretariat, Uganda, we also have the National One Health Platform. Just to add on to that, which it rotates, but there's Ministry of Agriculture involved, Ministry of Health, Ministry of Tourism, Wildlife and Antiquities, through what Uganda Wildlife Authority, and the National Environment Management, Ministry of Environment, where NEMA also comes in, National Environment Management Authority. And they're bringing in the civil society. Like our work over the years influenced such platforms to be created, and they bring us in periodically to talk about what we're doing. And actually, as you said, it needs to be more civil society focused. So I think in Uganda, we need to engage civil society much more. They need to be part of the National One Health Platform, not just advisors or people to engage with. I think that's very important. But how do we keep communities going? I mean, from the very beginning, we were giving them group livestock projects, which they requested for. And so even in between donor funding, they can have cows or goats or whatever it is that keeps them going. And they work without a salary, but this helps to keep them going even without a salary, because they're doing a community service. Their standing in the community goes up, so they like it. And on the community side, they're doing better. The status is going up. And this has helped them to keep them going. We haven't had volunteer dropouts for the past 18 years because of this group livestock or group projects, which then reinvest into village saving and loan associations. So bringing in microfinance as well. And we're finding that they keep going, because a lot of governments are reluctant to fund community health workers because they don't have the budget. But through our approach, we've shown that you don't have to fund them from government. You just have to keep them engaged and provide them with group livestock projects, which bring them together, and they can keep doing this work. So this is how we've managed to keep them going all through. But you need to get those communities to understand the impacts of climate change, the impacts of how to be more resilient. Even interventions like having the number of children you can manage. Family planning is a big climate change, climate action intervention, because a lot of people struggle when they have very large families, but if they have smaller families, then they're less impacted by climate change. So yes, it's a matter of looking at working with all the different kinds of disciplines. Somebody did ask in the chat about parts of northern Uganda where there's a lot of bushmeat hunting and eating. And some people don't have radios. They're too poor to have radios. So what we do is we work with these groups of community health workers. Uganda, we call them village health teams, teach them to do conservation work. So as they're doing their outreach, they talk about the dangers of eating bushmeat and all of that. But they're able to reach, each one of them reaches 25 homes, 25 to 30 homes every quarter. And they're able to reach them with important information. They collect data to see how they're changing over time, so that and then you can use the same people for surveillance and all these other things. Are there sick animals? Are there dead animals around? They're the same people who can provide all this critical information. As we're monitoring the health of the wildlife, the gorillas and other wildlife, at the same time, these community members become part of that monitoring. We actually work with some of them to actually collect these, samples from wildlife and bring them to the field laboratory at our Gorilla Health and Community Conservation Center for analysis. So yes, you can reach the communities where they are, and it can make a huge difference.
Thank you. Thank you very much, Gladys. So I'm really sorry we won't be able to go further in the questions from the chat because our webinar is now approaching to the end. There were still very, very good questions, but we will try to put them online on the webpage of our webinar, and we will ask actually our excellent speakers these questions offline, so we can still provide you with an answer. I really, really want to thank you all our audience for attending today's webinar, but most of all, our 4 wonderful speakers. I really, really appreciated this discussion with like so many interesting points and really, really important and timely information to be shared with all the PREZODE community. So thank you all very much, and I will give the floor to Catherine to wrap up this webinar. Thank you all again.
So thank you, John, Gladys, and Ian, and Cyril for your significant and impactful contribution, and thank you, Elsa, for your smooth moderation. I'm going to wrap up this session with a very quick overview on the main recommendations and outcomes we heard. So to mitigate climate change and zoonotic emergence, thus global health and pandemics, we need a prevention that requires a combination of solutions, such as improved monitoring and integrated surveillance systems, implement data hubs, sensitize and engage with communities from the beginning, especially in places where the population is the most vulnerable, provide help to food and livestock management and health security to communities, improve communication to get more people involved, and making sure that champions of community pass on the messages, use social media, develop modeling systems to anticipate change in the host population, understand how spillovers develop, and advocate at the policymaker level. So we know that the impacts of increasing weather conditions have a direct consequence on all living beings, whether human, animals, or environmental ecosystems. A One Health approach to climate change is crucial, connected to zoonosis emergence prevention. So this is what we, the PREZODE initiative, believe in and what we work with. Thank you all for attending the webinar today. Bye.